Well, good morning again. My name is Marty Ganser. Um, I'm a senior process engineer with Meyers Printing, primarily working in our Function47 group. I've spent probably the past 10 years working in printed electronics at Meyers as well as Sology and Molex. Prior to that, I'd like to start with a brief introduction to who Meyers is. Meyers is a printing company based in Minneapolis, Minnesota. We're a third generation family-owned business. We just celebrated our 75-year anniversary. Our core businesses are printed prime labels and packaging for the food, health, and beauty industries, which explains why we're here. It's a joke, it's a laugh line. In the graphic printing space, we're often solving problems for our customers with complex constructions, which over the years has led to a number of functional printing and converting applications such as battery separator membranes and electrosurgical grounding pads. And in 2019, Meyers was approached by one of our existing medical device customers they presented us with an opportunity to run our first project in the conductive printing space. Success in that project quickly led to a number of other printed electronics opportunities to address the growth and the increased demand of our printed electronics. Meyers invested in additional presses along with a dedicated engineering, operations, and marketing staff to service that demand. And in 2023, Meyers created the Function47 brand to lean into that functional printing space and to differentiate this business from our prime label and packaging offerings. We offer high volume roll-to-roll printing with rotary screen press in line with flexo decks and print up to 8 layers as needed. These presses also have abundant forced convection, typically specifically designed for curing, sintering silver inks. We also offer sophisticated converting capabilities with rotary die cutting, laminating, and singulating options. We currently supply medical device precursors, silver chloride sensors, the grounding pads that I've mentioned earlier, battery separators. And in the consumer electronics and aerospace industries, we successfully replaced etched FR4 panels with our printed electronics, reducing our customers' piece part cost to as low as 25% of their original cost of their etched parts. One of our sensor applications has a carbon flood base that's printed with a rotary screen. It's a charge carrying layer that requires a specific range of sheet resistance. We'd established control limits based on our historical data to keep us above a 2.0 CPK. But at the start of the program, we didn't have a consistent response whenever we went outside those limits. We had responses, but they weren't always consistent or effective. For example, the guy on second shift with a bunch of flatbed experience would want to try to mimic snap off by increasing the gap on the stork setting or on the RSI, which wasn't always effective. We had a guy on third shift who knew that he could get a heavier film build by putting more ink in the screen, but a guy puts more ink in the screen and eventually he puts too much ink in the screen and then you have ink all over the inside of your press. So we needed a standardized procedure for our operators so that they could respond the same way so that we could stay within our control limits. Well, I'm the sort of guy, you give me a problem, I'm going to throw a design of experiments at it. In this case, we started with a wide-ranging screening design, lining up all the usual suspects of line speed, ink viscosity, squeegee settings. From the screening results, we determined that the inputs with the greatest statistical effect and were the easiest for our operators to manipulate were the squeegee height and impression. The other variables, viscosity, fill volume, etc., all have significant effect, but they're difficult for the operators to affect on the fly. So then the next step was to generate a modified central composite design focusing specifically on squeegee height and impression as inputs and measuring sheet resistance as the main output. We did look at print quality, counting pinholes, but it really traveled really closely with film build. So it was basically all one model in the end. The final result was a pretty robust model, which I then had to turn into a tool that our operators could use. So we created this simple spreadsheet interface that has the model in the background. Our operators take a print sample at the end of every roll. They measure all the